Alright guys, I'm going to just walk you through a quick limit problem. Here's our problem. The limit is x approaches 1 of the function x to the fourth minus 1 over x squared plus x minus 2 multiplied by x squared plus 3x minus 4. Alright, so first, as with all limit problems, we're going to try and simplify it to factor out our equations that don't let x equal 1. So we factor this out, we get x squared plus 1 times x squared minus 1 all over x squared plus 2 times x squared minus 1 times x plus 4 times x minus 1. We can simplify that down again, this x squared minus 2 to x minus 1 and x plus 1, and then our two x minus 1s cancel out. Then we still have some complicated algebra left because we don't want to go through all the power rule stuff. So we split it to the limit as x is approaching from the positive side and x is approaching from the negative side of 1. So here's what our graph looks like to give you a rough idea. As x approaches 1 from the positive side, it gets super, super close to 1. The number's just over 1, infinitely over 1, infinitely close to 1, but it's still just a little bit over. So I picked an arbitrary random number and I left it to be 1.001. So 1.001 is somewhere over here, and we're going to plug that in for our x in this equation, and we're going to see what it gets us. So you plug in that over here, 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 and you get a positive. Whatever number you get is going to be a positive number over a negative number. The deciding factor in that is this part over here, the x minus 1, and because this number is just over 1, you're going to get a positive. So these are all positive times each other. These are all positive times each other, so you get positive over positive. That'll give you a positive number in the output, and that gives you positive. If both numbers are positive, it'll give you positive infinity. Over here we do the exact opposite. Our function is getting infinitely close to 1, but it's not actually reaching 1. So for our arbitrary point, I picked 0.99999 or 0.999, and you plug it in over here. You still get a positive on the top, but on the bottom, where this is x minus 1, because it's 0.999, you get a negative right there. So 0.999 minus 1 is negative 0.001. So you get a positive over a negative in the long run, which gives you a negative, which gives you negative infinity. And so because the limit as x approaches 1 from the positive side does not equal the limit as x approaches 1 from the negative side, the limit as x approaches 1 overall does not exist, or DNE. Alright, and that's how you solve an equation like that.